Well, welcome to another week. I'm excited to continue to learn as we walk through this unit. As we get to the end of this unit, we've kind of been looking at the idea of slope. We looked at a lot of things in this unit. We looked at dilation, we looked at similarity. Now we're going to kind of finish it up with slope. Now, last week we did talk about slope, and we kind of looked at a graph and looked at a way to find the slope of the graph to help us understand what it means. So this week, we're going to kind of take that a step further and look at more the equation side. What are available equations that we can use to find slope and help us identify that? So our learning target today is simply I can solve the equations for slope and point slope associated with graphical representations. So as we move into the engage section, in your own words, what does slope help us out with? So kind of use what you learned last week to kind of influence your thinking as you type some answers out to that question. And again, I'm not looking for no right or wrong answer. I'm looking for you to take what you have in your head and to put it on this document, all right, and be as detailed and descriptive as possible. And hopefully you're understanding the importance of that as we move through these math units. In the Explore section, you have resources there available for you. You have the Watch section and the Read and the Do. And again, these are meant for you to dive further into this topic. I'm going to be able to teach you as much as I can through this video, but those are for you to kind of refer back to if a step kind of gets confusing or you're trying to see what the process is like. So in the Watch section, you can view the video to help understand slope, and there's one for point slope equation. So those are the two equations that we're going to kind of focus on. And then the Do section, you're going to practice them. Put them into practice. So again, this is a section that's going to help you apply what you're learning to that elaborate section and the evaluate where you're completing checkpoints in your course. But what we're going to do is kind of look at that read section, right? Look at that resource like we do each week. And as you notice, the equation at the top is y minus y1 equals m and x times x minus x1. So what we say is, what do these things kind of stand for? Well, the x1 and y1 is just a point on the line, right? We looked at equations last week. We looked at the line on the graph. If we can find a random point, that becomes x1 and y1. Now, this resource uses x and y with no number. Now, I usually say there's an x2 and a y2, standing for a second point that we find. They kind of have it x and y there as another point, but I like to use x2 and y2 so that I know exactly that's the second point that we're finding. And m is simply the slope. So if we go back up here, all right, we're going to be able to apply and plug in or substitute points that we find for these two. And once we find the slope, it can be put in for m. And that's going to give us what we call an equation, a y equals mx plus b. Now, we're not going to get into depth with this because that's not what this point of the unit is right now. But we're going to kind of look at that, and that's going to help us determine if these equations can match with other points that we find. In your one of your checkpoints, it asks you, is this coordinate on the line? Well, we can use this point slope equation to say, yes, it is, or no, it's not, if the equations match up. And we'll go through an example here very shortly. So making sense of it, if the slope equation that we use is the change in y over the change in x, that's simply just y minus y1 and x minus x1. All right. So if I take it's kind of a snapshot of this video, and this is with my pen. So they kind of have this right here, correct? So what I like to do is I like, again, to put y2 minus y1 and x2 minus x1. So it kind of keeps them separate, right? So again, sometimes when we see x and y, we say, should that go after the 1? But if we have 2's there, we know that those go before the 1. So it's always y2 minus y1 over x2 minus x1. So if I look at this graph here, all right, and I say, okay, so x1 and y1 sort of look like 1, 2, 1, 2, 3. So we could say that coordinate is 2 over 3. And if we look at the second point, we sort of can say that it's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And we could say it's 6 over 4. So what I like to do is I like to label them right below it, right? So that kind of helps us understand what we need to plug in when we come to this equation. So if I take y2 minus y1, I'm going to take 4 minus 3 and 6 minus 2. And what that's going to give me is 4 minus 3 is 1, 6 minus 2 is 4. So it says my slope is 4. Now, if we go back to that graph and kind of use what we did last week, we could find out if that's possibly true. So if I go up 1, which is rise, and then run 1, 2, 3, 4. So that works. So my slope ends up being 1/4, which is the m in that equation. So again, that's how we find slope. That's how we use the slope equation, but we got to make sure that we identify which one's the 1s and which one's the 2s and plug them in appropriately. So if we continue to kind of move down here, there's examples that you can look at on how to solve the equation and things like that, but we're going to kind of run through this example together so you know exactly what this kind of looks like, okay? So this is going to help you complete the evaluate section, all right, matching the relationships to graphs and is the point on the line. It's also going to help you with this activity where you're showing your understanding of slope and point slope equations with a graph. And you're going to kind of tease out what you've learned and apply it, and again, be able to say, I can solve these equations from a given graph. But before we do that, what I'd like to do is kind of look at an example here for you. I'm going to kind of take a picture or snapshot of my screen, and hopefully this is helpful for you as well. So if we look at this example, we're going to find slope first, right? So we need to find our m, which again is y2 minus y1 over x2 minus x1. But we need to find 2 random points. So what we can do is, and what I always try to say is find the spots where it hits a corner, right? So here it hits a corner, and here it hits a corner, because those are a little bit more easier to find than those that are in between lines, and we don't know if they're halves or quarters or point whatever. Find where it crosses a given corner. So if I look at this one, all right, as a coordinate, this one is not moving, so it's a 0, but it's going up 3. This one over here, and actually what I'm going to do is change that to this one to kind of maybe, we probably can use this one up here because that's going to cross. Let's keep everything positive. It's positive sometimes makes things easier. So we'll kind of look at this and we can say it's going over, well, here we have 2's, all right, 2 and up 1, 2, 3, 4, 5, which it looks like it is 10. So I apologize, I was not paying attention to that. So this one would probably be 6. So it's going up 2, 4, 6. So we got 2 coordinates, 2, 10 and 0, 6. And what we can do is say this is x1 and y1, this is x2 and y2. And we're going to take that and plug that into our equation. So y2 is 10 minus y1 is 6 over x2 is 2 minus 0. And what we're given is 4 over 2, which ends up being a slope of 2. And how we can apply this is that going to work on the line? Well, what we can do is we can take the 2 points that we found and say if we rise 2 over 1, it does work. So there is our slope, okay? Now, what we need to determine, all right, is our equation from that point slope problem. So if you notice, it has y1 and x1, so we're just going to use 0 and 6. So if I plug y1, that's 6, the slope is now 2, and my x1 is 0, all right? So if I solve this, we use the distributing property, which means 2 is being multiplied to every term in that problem. So what I get is 2 times x is 2x, and 2 times 0 is simply 0. So we could say minus 0, because we're going to keep that sign. Then what I need to do is get rid of that 6, and since it's subtracting, I'm going to add. And when I add it, I need to add it to the common term on the other side. Since it doesn't have an x, I can't add it to 2x. So what I'm left with is 2x plus 6, okay? So in that equation, what we say is that the 2 is the slope, and then the 6, what we say is it becomes our starting point, and we call it the y-intercept. It's actually b. If you look at it, a y equals mx plus b, but it's our starting point. Is that our y-intercept? Meaning, is that the point that where it hits the y-axis, our starting point? If we go up here, it does, right? So the 6 matches that. That's where it hits the y-axis. So this equation is correct. All right. So what we need to do then is, if I ask you the question, which is going to be one of your checkpoints, does the point, and I'm just going to be random with it, does the point, let's look at, does the point negative 2, negative 2, 2, does the point negative 2, 2 work? Is that a point on this line? What we would do is we would take this equation and we would plug the x and the y into the equation. So 2 goes in for y, and then we got negative 2 in for x. And then what we can say is we could solve, right? 2 times negative 2 is negative 4. And then negative 4 plus 6, if we use our integer rules, all right, would give us a positive number of 2. If these two equal, we say that yes, that is a point on this line. If these two do not equal, if you get something like 2 equals 4, then you would say no, it is not on this line. So what we can do is use this point slope equation. Once we establish what that equation is, this is our equation for that line, we can plug in y and x from any random point that we want to come up with to determine if it falls on that line. But what we need to do first is to develop, all right, that equation, okay? Now, another way to look at this, to bypass this point slope equation, sometimes we can just simply plug in numbers for the letters and based on what's given on the graph. So our equation is always set up as y equals mx plus b. M is the slope, b is our starting point. B is where it crosses the y-axis. So this is the y. What we could say is we already found the slope to be 2, and our starting point is 6, which is plus 6. So bypassing this process here, we could simply just plug in the numbers that we can identify on the graph, which again is another way to look at it. But if it's hard to identify where this point meets, we can use this equation. But if this is something you can do, that would eliminate this process here. But again, I kind of wanted to give you everything so that you can kind of see it all at once. All right, so remember, the b is where it crosses the y, and the m is your slope. And then once we determine a point, a random point, we plug it in for y and x to find out if that equation is true and if that point falls on that line. So again, you will use that in it is the point on the line. So they're going to give you a random point and you can kind of use this process. But come back to this video and kind of pause the video where I instruct and then apply that to what you're doing and kind of go back and forth as you're learning the process. So don't be afraid to do that. So hopefully this helps you for the activity, and hopefully at the end of that, you can with confidence say, I can solve the equations for slope and point slope associated with graphical representations. And if you have any questions, please let me know. Continue to work hard and we'll kind of move through this unit together. Have a great week.